Hello AP Stat students and welcome to another exciting special problem. Today we're going to be looking at a special problem for chapter 5. Hopefully you've already read it. Basically what it's telling us is an airline has a very small commuter plane. It's 30 seats capacity. They've kept track of no-shows, which is wise, and they've found that they average 8% no-show rate. Right? So that means these customers have bought their ticket and they don't even show up. And I don't know if you know much, but if they don't show up, they don't get their money back. So airlines like it when you don't show up, and that if they can sell those empty seats. And so that's what they've asked. What if they try selling 31 tickets, assuming they're going to have a passenger or more not show up for each flight? Then they could make more money. Now, again, I don't know how much you've flown, but sometimes more passengers show up than seats, right? They anticipate some no-shows and, oh no, there's not enough no-shows. When that happens, they'll give out a voucher, right? They'll give you a certificate that you can use on it to purchase another flight in the future, and they will also accommodate you on the next flight. So the question is, in the long run, is this a profitable idea? Should they be selling 31 tickets for their 30-seat plane? Or, notice what I've written here in bold, or is there another option that's better? Okay, and it tells us to use simulation methods to answer the question. So let's do it. All right, step 1 to a simulation, describe what we're doing. So we're selling 31 tickets for a 30-seat flight. Okay, our assumption, that's step 2, 8% no-show rate. Okay, now assign, well, there's one more part of this assumption. We're also assuming independence, right? If we have lots of large groups, then we would have like a whole group possibly no-show one flight and then nobody no-show the next flight, etc. So let's throw that in there too. And independence. Okay, assignment of digits. I'm going to track the no-shows. That's easier, so I'll start with no-shows. Okay, now let's simulate. Obviously, as we've discussed, the more simulations, the better. I don't want to spend 5 hours here, and I'm not going to write a computer program to do it because that's not our class. However, those of you that know how to write a program for this and you could simulate a million trials, go for it. You'll get a nice, accurate answer. I'm just going to show you the process using our calculator, and we'll just do it 20 times, and hopefully we will get at the correct answer. But there's really not a guarantee, right? There's a chance that we get an incorrect conclusion with only 20 trials. But we'll give it a shot here. Okay, and I'm going to count the number of no-shows. So here we go. You could use your random digit table, but the calculator is nice because you can sort. I'm going to show you how to do that. So go to our math menu for our random integer function. Okay, and remember we have multiple choices. Here's a newer calculator. So I could do a regular random integer, or I could do a random integer with no repeats. So take a moment and decide which of those two is appropriate for this scenario. Okay. So the regular random integer is, of course, the appropriate choice, because if you were removing numbers as you move forward, you'd be changing the 8% no-show rate. So that would mean that it's not independent, and we did assume independence, which might be a bad assumption, but we have to do that to do the problem. Okay, and perfect. So lower bound 0, upper bound 99, and we're going to do 31 trials. Sell 31 tickets. Okay, now I could scroll through that list and count. There's my wonderful dogs in the background. I could scroll through this list and count, or here's a fast way to do it. If I go to list, actually, let me go back. What I want to do is store it in a list. So down here, STO, press that. I'm going to store it into list 1, like this. Okay, now that it's stored, I can go into the list menu, go to operations, and I can sort the list. Okay, so now when I look at the list, I can really quickly see how many no-shows I had. Hey, first trial, I didn't have any no-shows, so I overbooked. I'm overbooked by 1. Okay, so now that person gets a free voucher and they will be on the next flight. So I actually have potentially 32 people showing up to this next flight. Okay, so we do it again. Now here's a shortcut. If I hit second and enter, it gives me the last command. If I now hit it another time, it gives me the second to last command. So I'm going to do that. I'm going to do second enter, and I'm ready to see my next trial. This time I had 1 no-show. But I actually needed to accommodate 32 passengers, so I'm still overbooked by 1. Okay, and continue. One, two, three. This time I have 3 no-shows. And that means I actually had 1 empty seat on that flight, right? Okay. Next trial. 1, 2, 3, 4 no-shows. Okay, maybe I should keep track of empty seats. So I've had, over here I'll say empty seats. Okay, right there I had 1, and this time I'm going to have 3. Okay, let's go again. And 2 no-shows, so that's 1 more empty seat. One, 2, 3, 4 no-shows, so that would be 3 empty seats. Two no-shows. 1 more empty seat. One, 2, 3, 4 no-shows. 3 more empty seats. Starting to see a trend here, but again, it's not that many trials. One empty seat. Okay, so that's perfect. Well, 1 no-show, no empty seats. That's perfect. That's what we really like to see happen. And again, 1 no-show, perfectly full flight, not overbooked, no empty seats. Okay, 1, 2, 3, 4, 5, 6 no-shows that time. So that was 5 empty seats on that plane. Two no-shows, so 1 empty seat. And 2 no-shows, 1 empty seat. One, two, 3 no-shows, 2 empty seats. 2 no-shows, 1 empty seat. One no-show, perfectly full plane. Two no-shows, 1 empty seat. And 3 no-shows. So 2 empty seats on that plane. All right, 1 no-show, so perfectly full plane. And 1 no-show, perfectly full plane. Okay, so here we go. Here's my data. I ended up at the end of 20 flights giving out 2 vouchers, but I actually sold an extra 20 tickets, right? So comparing to just selling 30 tickets, right, I can see we sold an extra 20 tickets and gave out 2 vouchers. Now, assuming the vouchers are of equal value to the tickets, which is a big assumption, again, in overbooked situations, they'll offer, say, a $50 voucher. If somebody takes it, great. If nobody takes it, they'll up the offer, maybe $100, and they'll continue to up the offer until somebody takes the offer. So at some point, somebody's actually happy, right, to get that voucher. I know when I flew a lot in college and I was poor and I would get, my parents would buy me that one trip home for Thanksgiving or Christmas, and I'd be like, please be overbooked, please be overbooked. You know, that way I could get a voucher and then I could come home, you know, at another point for free, right? So there are people out there that like these vouchers, so don't worry about that. What we're gonna worry about is how much money do we make in this situation. So we'll assume the vouchers are of equal value to the actual tickets. So that means we have a net of 18 extra tickets. So we are plus 18 ticket sales. Okay, so after 20 trials, it looks like this is very likely better than selling just 30 tickets. Okay, but notice this over here, right? Quite a few of our flights actually had more empty seats. So would selling 32 tickets be even better than selling 31 tickets? Right? That's why in the problem I wrote in bold, is this the best option? It may not be. Let's continue. Let's try a simulation where we sell 32 tickets and see if that is better than selling 31 tickets. Okay, same steps. Okay, and same assumptions. Independence, meaning each person on the flight is independent, which is, again, kind of a bad assumption. A lot of times people do travel with someone else or even a whole family, but we have to make that assumption in order to do the problem. Same assignment. And again, I'm going to do 20 flights. I know it's not enough, but we're already at 15 minutes of your time. So if this were an actual thing we were getting paid to do, we would do a lot more than 20. But hopefully this will kind of get at the process and you'll understand what's going on and make make the correct conclusion. Okay, and again, track the number of no-shows. And this time maybe I'll just write number overbooked. And on the left, I'll keep track of empty seats. Okay, here we go. So all I have to do is bring back that command, and this time make it 32 numbers instead of 31. Okay, so first flight, I have 1, 2, 3, 4, 5, 6, 7 no-shows on the first flight, which means I actually had 5 empty seats right there. Okay. And second flight, 1, 2, 3, 4, 5, 6 no-shows, which means I had 4 empty seats. This time I only had 1 no-show, which means I am overbooked by 1. So on my next flight, I'm actually trying to accommodate 33 passengers. One, two, three, 4. 4 no-shows. I was attempting to accommodate 33 passengers, so I do actually have 1 empty seat here. Okay. One, 2, 3, 4 no-shows again. So this time I'll have 2 empty seats. And finally have a perfect result there. Overbooked by 2 no-shows, so perfect. And 1, 2, 3 no-shows, so 1 empty seat. One, 2, 3, 4 no-shows, 2 empty seats. One, 2, 3 no-shows, so 1 empty seat. And 2 no-shows, so perfect. Full plane. One no-show, so we have an overbooked situation again. Okay, so on my next flight, I need to try to accommodate 33 passengers. And 1, 2, 3, perfect. We have 3 no-shows. That's exactly what we needed to be perfectly full on that flight. And 1 no-show, so we have an overbooked situation again. So we again, in this case, need to accommodate 33 passengers now. And 2 no-shows, so we are still overbooked by 1 passenger here. And 1, 2, 3. Okay, so that's perfect. That's what we needed. And 2 no-shows, perfect. Oh, 1 no-show, so we have another overbooked situation. So we need to try to accommodate 33 on our next flight. let's see, that's one no-show. So we now are overbooked by 2 passengers. So we need to try to accommodate 34 on our next flight. Oh, wow, 0 no-shows. So we now have 4 passengers waiting. So we're going to try to accommodate 36 on the next flight. And 1. So we're now overbooked by 5. Okay, so basically you can already see that 20 trials really isn't enough. Things were going great. We had all these empty seats, and in the beginning you're thinking, my goodness, why aren't we selling more tickets? But then all of a sudden at the end, we got slammed by kind of a bad run, and now we're ending with 5 passengers additionally on top of our 32 that are coming for the next flight. So it looks like now all of a sudden it looks like, wow, this is a terrible idea. It's totally backing up. It's never going to work out. So you can see 2 extremes happened in the same short set of 20 trials. And that's why you need to run this many times to actually get at what's the best situation. 31, 32. I'm not going to bother with 33. You can already see, and I'll explain why in a second. So let's total this up. So we actually sold an extra 40 tickets here. And how many vouchers did we give out? 1, 2, 3, 4, 5, 7, 16 vouchers. Okay, so that's a net of 24. So we are plus 24 ticket sales compared to, whoops, didn't notice that wasn't on the screen. We're plus 24 ticket sales compared to just selling 30 tickets. Right? And we can see our other simulation, we were plus 18 ticket sales. So over this span of, again, limited span of 20 trials, we can see that selling 32 tickets appears to be better, but again, we need many more trials to really make sure and have this sink in. Okay, now let's actually talk about, I'm going to show you something that we haven't learned yet. We're going to be learning it in the near future, right, this semester. It's called expected value. Right, we're saying 8% of the people don't show up. So if you sell 30 tickets, right, well, what's 8% of 30? So on average, selling your just 30 tickets for your 30-seat plane, on average, you're going to have 2.4 empty seats. So clearly, you should try to overbook your plane. Okay, so well, what's 8% of 31? Okay. So if you sell 31 tickets, on average, you're going to have 2.48 passengers not show up, and that'll be fine, right? In the long run, you're still going to actually average an empty seat, a little over an empty seat. So what's 8% of 32? Okay, 2.56. So again, over the long haul, selling 32 tickets, you're going to average 2.56 passengers not showing up. So over the long haul, this is going to work out, right? Over the short run, maybe not, right? You're going to have some strings where, like at the very end of our, right, at the very end of our simulation, you're going to have some runs where things are not looking so good, but over the long haul, it'll work out. And you go, well, what about if we tried selling even more tickets? And here you notice, hey, that's not going to work out. Right? if I try to sell 33 tickets, I'm only going to average 2.64 no-shows per flight, which is less than my overbooking. So selling 33 tickets would only make sense if your vouchers that you're giving out are less than the flights. But even then, that's at the end of the day, you're going to have passengers you're going to have to deal with that didn't get on the last flight of the day, which that could be a problem. I actually do remember a situation where I took a voucher for it was the last flight of the day. It was overbooked. Took a voucher, and they gave me a hotel room. But that was a long time ago. Not all airlines do that anymore. But that costs money, right? So you don't want to overbook to the point that in the long run it's not going to even out, right? These passengers would keep backing up and backing up and backing up over time. You'd never get them where they're to their intended destination. So, conclusion, there's our best option. And you're saying, well, there's still going to be like a half seat, right? You're going to average like a half seat. So every other flight or so, you'll have an empty seat. And that's why airlines do one more thing. They sell standby tickets. So standby tickets, they're not guaranteed on any flight. They just hang out and they stand by. And if there is that empty seat, then they get to take that seat. And you go, well, why would anyone ever purchase standby? That's silly. Well, they sell those tickets at a discounted rate. So that's their way of trying to fill in that extra 0.56 on average empty seats per flight. They'll sell some standby tickets. So they're trying their best to maximize their profits that way. And they don't have to give any vouchers to those standby clients if the plane is full. So it works out. So conclusion. Selling 32 tickets for the 30-seat flight is the best option to maximize profits. And again, this is assuming the vouchers average the cost of a flight, right? Okay. So hopefully that makes sense to you, and hopefully you haven't taken a Chapter 5 test yet, in which case I wish you good luck for the test.